So here's a hypothesis test. So what I want to do here is I want to find the value of the standardized Z statistic. I'll remind you of what that is for a given hypothesis, sample statistics, and standard error. So I'm given my hypothesis here. So my null hypothesis is that I have a mu that's thought to be 85. And my alternative hypothesis is that the mu is believed to be greater than 85. And remember, for the null and the alternative hypothesis, the null has an equals, the alternative never has an equals in it. That's how we choose which is which. Then I've got some sample data. I have a sample of size 25. My sample had a mean of 85.036. Now the question is it's higher, right? But is it a lot higher? That's what we got to look at next. And that depends on things about the population, in particular, the spread. Now, S, that's the sample. This SE over here, that's the sampling distribution. And that right there is what I need to make some calculations. So there's 3 different ways we use z-scores in this kind of thing. One way is this idea of a standardized test statistic. Played with this a little last class in previous videos. Standardized test statistic. And it's going to look something like this. It's going to be usually a sample information, maybe the sample mean or the sample proportion, minus the population information, which is generally from the null hypothesis, divided by the standard error. So in this situation right here, for my Z, I would take my X bar, subtract the mu from the null hypothesis, and divide by the standard error. And the standard error either has to be given, found in a sampling distribution randomization, or calculated in another way we'll talk about next week. So for now, I'm just going to give you the standard errors. So pretty much any problem I ask like this, where I want you to find, say, a Z or a P or a margin of error, I'm going to say, hey, this is the standard error. So pay attention to that. All right, so for this one, I get 85.036 minus 85 divided by the spread of the sampling distribution, 0.72, and we whip that out on a calculator. And here I just need a regular calculator. So I'm just going to bring that off the side so I can see my numbers again. Double check me on this in case I mistype anything. 85.036 minus 85 divided by, oops, not subtract, divide by 0.72. All right, so if I typed it right, let's bring this over here and take a look. So I've got my 85.036 minus 85 divided by 0.72. I just type that in Google search, Google whips out the calculator, and I get 0.05 as my z-score. .05. All right, reminder, what is a z-score? A z-score counts standard deviations. So if I think about a normal distribution, which is that symmetric bell shape, and it's a good idea to draw pictures with any problems like this from now on. If you haven't been doing that in your notes, I can encourage you to do so. So here I'm going to put mu in the middle. And mu in the middle is a z-score of 0. We haven't left the center. Standard deviation counts how far away from the center are you. And with z-scores, we expect within 1, 2, 3 standard deviations on each side. So 1, 2, that would be -3 on the other side. So here z equals -3, here's z equals 3. We expect about 99.7% of the data to be in that range right there. Within 2 standard deviations, we expect about 95% of the data to fall in there. And that data could be the population, the data could be the sampling distribution, if they have a normal distribution. So for us, the only thing for sure that has a normal distribution is the sampling distribution. And that's what this spread is from here. Sampling has a normal distribution. Now we get a z-score of 0.05 right there. Well, if this is 1 and that's 0, 0.05 is like right here. That's my z-score is right here. So is 85.3036 far from 85? The answer is no, it's snuggled up right up against it right there. Okay. If I were to calculate a p-value for that, this question didn't ask that, but the p-value would be what's the chance of being bigger than that number right there? My p-value is going to be pretty darn close to 50%. Right, which means, this data seems to support the null hypothesis, so I'm just going to fail to reject the null hypothesis. All right, so the point here was calculating a z-score. One way to calculate a z-score is given a null hypothesis and sample statistics and the standard error. So we need information from the population, information from the sample, and we need a little information about the sampling distribution. 3 separate things have to come together. All right, let's try another one.